Okay, this is 2018, problem number 6. They have created a slope field for us down here, and we have to sketch one curve that passes through 0, 2, and then sketch a curve that also passes through 1, 0, and they even gave us the point. So if you look at 0, 2, these slopes are 0, so you must draw a horizontal line across from one end to the other. If you don't go all the way across the graph, you don't get the point. And then the other graph has to go here through 0, 1. So as you come up, this thing is starting to curve to the right. And again, you got to go all the way out to the edge. And then you're going to have to come down here. Come on, Penny. You're going to come down here, and then you got to come up. And it's got to go all the way over here to the right. Now, if you notice, there's that horizontal line at 2. You are never allowed to pass that graph. If you would have made this blue graph, and I'm going to make it differently, you would have lost your point. If you would have come up here and drawn something like this and crossed this line, you would have lost that point. You are not allowed to cross that horizontal with a line on these graphs. So make sure you don't do that. Okay, problem B says let y equal f of x be a particular solution to the differential equation. With the initial condition 1, 0 is on the line, write the equation for the tangent line to the graph of f of x and x equals 1. Use your equation to approximate 0.7. So they gave me a point right here, 1, 0. And up here, they gave me the slope of this function. So I've got to plug 1, 0 into that slope, or into my derivative. So dy dx, which is my slope. And then I got to plug 1 in for my x. And I plug 0 in for my y. And then I'm going to solve that. So that's going to be 1/3 times 4. That's going to be 4/3. So my tangent line is going to be y minus 0 is going to equal 4/3 times x minus 1 from my point and slope. So there's my tangent line. So you get one point for that. And then it says approximate using that the value of 0.7. So y minus 0 is just y. And then I've got to take and plug in over here 0.7. Now you can quit right there, and that is your approximation. If you want to finish this out, this comes out to be a negative 0.4, but you should not have to simplify that. So that's part B. I'm going to erase all this for part C because it says find a particular solution to y equals f of x to that differential equation. And again, we're at the point 1, 0. We're going to need that later to find C. So we're going to use this diffie-q up here, the one they gave us at the very beginning. And we have to do like we always do. We have to separate. So we got to take y minus 2 squared and divide each side by that. We got to get that y minus 2 squared over to the left side with the dy. And then we've got to get the dx over there with the 1/3 x over there with the dx. And then we are going to integrate, and we are going to integrate. So we are going to want to let u equal y minus 2. So du is going to equal dy. So when I do this integral over here, I get 1 over u squared du. And then over here, I'm going to have 1/3, and I'm going to have x squared and put that over 2 plus some c. So on the left side, I've got to bring that u up to the top because it's not just a regular u. If it's u to the first, we would have a natural log, but it's not. And then over here, I'm going to have 1/6 x squared plus c. And now I add 1 to -2, which is going to be u to the -1 over -1, which just brings the negative out front. And then I'm going to write that -1 over u, but I'm going to plug back in my y minus 2 over here. I think I'm going to plug in my 0, 1, 0, this thing down here in, and find my c right now. So I'm going to have -1 over -2, which I hope you know that makes positive a half. Is going to equal 1/6 times 1 squared is just 1, so that's still 1/6. So I'm going to have 1/2 minus 1/6 is what c is going to equal. So I'm going to change 1/2 into 3 over 6 with a common denominator multiplied by 3 over 3. So that's going to be 2/6 or 1/3 is my c value. So now I've got to plug that c value back up here into there where it's right into there where I did it. So I'm going to erase this left side because I'm going to have to solve this for y. And then I'll be done. So bear with me while I erase this stuff over here. So that's going to give me -1 over y minus 2 is going to equal 1/6 x squared plus 1/3. Now what I'm going to do now is I'm going to divide each side. Well, I think I'm going to divide each side by -1. So that's going to equal, so that's supposed to be a 2 there, a -1/6 x squared minus 1/3. And then I'm going to flip everything upside down. So I think I want to get a common denominator over here. I'm going to make this 2 over 6. So I think I'm going to rewrite this side over here as -x squared minus 2 all over 6. And I got y minus 2 here. So the last thing I'm going to do is add my 2 over. I will have 2 minus, I could put that at the fraction bar, and I can make the, oops, since I flipped this one, I made a mistake there. This is still 1 up here. So actually, let me go back and do a couple more steps here. So I don't want to freak anybody out. So I'm going to take this fraction on the left, and I'm going to flip it upside down so that I have y minus 2 over here. Which means on this side, I got to flip this one upside down, but I'm going to bring the negative out front with the fraction bar. And that's going to put the 6 up top, and then that's going to give me x squared plus 2 down here. So I basically just factored the negative out. You could put it with the 6, and then that's going to end up equaling, that's going to give me y is going to equal 2 minus that 6 all over x squared plus 2, and that will be my answer right there. So kind of a hard problem.